So before discussing DevOps, we'll be discussing that how DevOps came into picture. So DevOps means, if we define DevOps, like people, process, and automation. That's what three words in which we can define DevOps: people, process, and automation. When people comes together from different teams, they come up together. Like you can see in IT, when you talk about, there are different fields: administration, operations, development, testing, support. So when all these people come together, they form a process, or they collaborate and form a process. And with the help of automation, they achieve the desired output. So that's why I call it people, process, and automation. But how this came into picture? So if we talk about earlier development process, okay, so or old development process, or you can say traditional development model. So there was a model known as SDLC, software development life cycle. SDLC model. So if you want to develop something, you follow this model, software development life cycle. Now, inside this software development life cycle, when people used to develop something, they get a requirement, they used to develop something, develop any application, any software, any product, any solution. So they follow SDLC model. Now, inside the SDLC model, when there was no automation, when there was no cloud into picture, nothing. So they follow a model in this SDLC. And in that model, now this is the first kind of old model I'm talking about. So there are some steps to be followed. Okay, consider these diagram what I'm creating as steps. Okay. And these you can consider as they are interconnected. Means every process is done by after the previous process has been completed. So you can consider it like this. Now, whenever you start developing something, very first thing is the requirement. Very first thing is the requirement. Now, here can be your product owner. Product owner, this can be your client as well. Now, product owner is there. Then this is your organization. Very first thing, what we will be doing is gathering the requirement. Second step is doing the analysis. So when you are doing the analysis, you might be defining that analysis into some documentation. So there is a documentation. We'll write here documentation, or just write documents. Okay. And these documents are known as system requirement. Okay. SR or SRS, system requirement specification. After this requirement analysis, what else will come into picture? Planning and design, right? So design. Then source code, writing the source code. Source code. Then what else? Testing. And deployment. And once it is deployed, monitoring and support will come into picture. Monitoring and support. So this is the step-by-step model which you follow, or which is previously followed, right? There's a product owner. Now, who gathers the requirement? So some highly qualified technical person will be there. So you can consider that there's a person which we call as a solution architect, right? Solutions architect. So that person will sit in and he might gather the requirements. Now, once the requirements are gathered, then he will do an analysis. Who will do an analysis? Solution architect only. So solution architect will perform an analysis over here. Then later on, what he will do? He will design. Once the design, the flow diagrams, all those things are created here, then who will come into picture? Who will write the source code? So developers, right? Developers will come into picture and they will write the source code. Once the source code is written, testing will be done. So who will do? Testing team, definitely. Testing team or QA team or any. For deployment, who will come into picture? Operations team, right? Operations. And then there is a support team for monitoring and support. So here we can write application support. Application monitoring and support. So now you can see that everything is done one by one here. And since everything is done sequentially, earlier this model was called as sequential model. Sequential model. Or there was one more name, waterfall model. Waterfall model. This was the first model under software development lifecycle which came into picture, and everything was done one by one here. So there are some drawbacks with this. Earlier it was popular, but later on people found drawbacks with it. So what were the drawbacks? So these drawbacks were long time to develop and no proper resource utilization. These were two drawbacks. So why long time to develop? The solution architect is gathering the requirement from the client or the product owner. Okay. So it might take 15 days, 20 days. Let us consider it might take at that particular time, it might take around 1 month. Then doing the analysis, writing the documents, SRS document, 1 month. Now, what is this SRS? System requirement, right? System requirement. System requirement. Documents. So it will take again 1 month. Then design, he will design the flow diagrams, he will write some documentation regarding design and all, 1 month. Developers will write the source code. For example, there is some, so there are applications like my monolithic applications, or you can say small scale application or enterprise scale application. So if it is some kind of enterprise scale application, some big application is there, then it will take time to write the source code also. So say 1 month. I'm just assuming this period at that particular time in 90s or 80s when this was the model to develop something. So 1 month, then again 1 month, 15, 20 days. For the deployment team also, they will deploy and test again and again. So in this way, it takes very long time to develop. Long time to develop. Say 6 to 8 months. So you can deliver only single project. And second is no proper resource utilization. Why no proper resource utilization? Because every step is coming after one step. Step by step process, waterfall model, sequential model. So sequential model or waterfall model, every step is done one by one. So what will happen? Say for example, I'm starting a company, I have one project, single project. There's only one team. I have only this much of team as I'm just started with my company and all. So I can hire this much of team. That's it. And they can only work on single project at a time. What will happen? Until and unless requirements are gathered, until and unless analysis is done, until and unless design has been completed, developers cannot write the source code until they get full design, architecture and all. They cannot write the source code. Until the source code is not written, testing team cannot test the source code. the vulnerabilities in the source code, all those things, test cases. Okay, they cannot test until unless the testing is completed. Deployment team will not do anything. So there is no proper resource utilization. There is a dependency. So to overcome these drawbacks, they came up with another model after that. So they came up with Agile model. Now in Agile model also we have steps. But comparatively less steps than the waterfall model. Product owner, client, or anything you can call. Then here is a scrum master. Then there's a scrum call process, and then sprint. Now in the agile model, to overcome these drawbacks, long time to develop, no proper resource utilization. Now what is being done? Say for example, any application is developed over here. Say that is a microservice application. It's a e-commerce application. Now what this Scrum Master will do, we have a project like e-commerce application. So we will divide this project or divide this application into modules, small modules. Say you have first module, login, login module. Then you have product. Then you have cart where you add the products. And then you have payment. Payment module is important. And later on, what he will do? So he divided this, since agile model is all about management, project management. Okay. How a project can be managed. So Scrum Master, what he will do? Very first thing, he will do a Scrum call. Scrum call with whom? With the team. So what he will check for? So very first thing he will check for the team availability. Team availability. So in the team availability, so for example, there are 10 developers. 10 developers are there. 8 testers are there. 4 people from the operations team. This is the team availability. Now he will again check for the team capacity. Now I'll explain you what is the team capacity. Now, for example, there are 10 developers, but 2 of them are on leave for this week. And if each developer can do 1 hour of the development work each day, so in 5 days, how many hours of development activity they will do? 5 hours of the development activity. 5 developers are there. Each day, 1 hour of the development activity. So 5 hours of the development activity. So what is the capacity of the development activity for me on that particular week? 5 hours. That is the, but 2 of the developers are absent. They are on the leave. So now out of 5 hours, what is the capacity left over here? Since 2 are on the leave. So 5 minus 2, that is 3 hours. So I have the 3 hours of the capacity left with me. So for this particular week, I have to work on that 3 hours of capacity only because 2 are not present. So he will check for the team capacity. Say, for example, I'll check it for next 1 month. That is why people say in the IT that if you want to go on leave, please make sure that you apply the leave way before, like 1 month before, so that the team capacity is being properly planned. So that is what team capacity. So how many members of the team are present at a particular time period. So that decides your team capacity. So you'll check for the team availability and team capacity. Now, after gathering this team availability and team capacity, what he will do? Scrum Master. Now he will connect to the product owner again. For what he will connect? He will connect for gathering the requirement. And what he will do? Since the application has been divided into smaller modules now, so he will gather the requirement for login module first. So gathering the requirement for login module. So after gathering the requirement, he will deploy his team to work on that module. Now, inside this module, login module, what will be developed? So features will be developed. Features will be or get features will get or will be developed. What feature? So say login feature. Login feature. So what he will do? He will deploy 2 developers to develop this login feature, plus 2 from the testing team to test the feature, 1 from the ops team to deploy that login page or whatever they developed as a feature and test it. So for login feature. And this time period will be called as sprint 1. So sprint is nothing but the time period. Sprint time period. And it is of 2 weeks. Somewhere maybe 3 weeks as well. But 2 weeks is like most popular. So sprint is equals to time period. So this is sprint 1, which will go for 2 weeks. Now what will happen? Again, he will gather the requirement for product module. Gathering requirement for product module. I don't want to waste the time, so I'm doing that for card module as well and for payment module as well. So here also features will be developed. What features? Product page. Product page. Here what features? cart, where the products are added. And what features here? Payment. Now features can be different in the payment module. Payment from credit card. This is one feature. Another feature, payment from debit card. Another feature, payment from maybe UPI, right? Then they are coming with new features like pay later program, pay later, right? So these are different features. Here it can be GPay, it can be phone pay, right? GPay, phone pay. So like this. Okay. So two developers here, again, two from the testing team, and two will be from, sorry, one will be from the ops team. And this is for product. This is for card, and this is for payment. Now see what he did. So you can consider the second one as sprint 2. You can consider this as a sprint 3. Consider this as sprint 4. And each of the things will be done, like you can say it can be done parallelly also. If you have large number of team, it can be done parallelly, everything. So in this way, what will happen? Now, what were the drawbacks over there? Long time to develop. So they become advantages over here. So short time or less time to develop, I'll say. Less time to develop. Now, if enterprise applications are there, then it may take around 2 months to develop. Some small scale applications are there, you can develop in 15 days, 20 days, 2, 3 sprints. That's it. So less time to develop and proper resource utilization. Since everything is done parallelly here, 2 developers are involved here, 2 are here, and everyone is doing their own work. Testing team, some people they are testing the login page, some people they are testing the product page, some team they are testing the cart page. And everything starts from sprint 1 only. Now, for example, if something is left in the sprint 1, what can happen? It can be carried out into the sprint 2. Means in the sprint 2, they will work on the product feature, but they will make sure that whatever is left out for the login feature in the sprint 1, they should complete that as well. So in this way, it is all managed. So now proper resource utilization is there and it takes less time to develop. So that is a agile model. And earlier they were using sequential model. Now there are drawbacks with agile model as well. Drawbacks with agile model. What were the drawbacks which came into path for with the agile model? So one drawback was manual releases. Okay. Or you can say no automation. No automation. So since there was no automation, what you have to do? You have to do manual releases. And since you are doing manual releases, high chances of error. So if you do release management, all those things manually, high chances of error there. So these were the drawbacks. So now what they did? So they combined agile model with DevOps automation. They combined agile model with DevOps automation. And what they used here for DevOps automation? So DevOps tools. DevOps tools. So while using DevOps tool, very first tool for automation was in DevOps. So they are using version control. Version control. or you can call it as source control as well. Source control. SC or VC, version control. Now, what is this version control or source control? So they came up with centralized source control, centralized or centralized version control. Explain you what is centralized version control. For example, there is a developer. I'm a developer. I'm developing something. I'm working on this is my working copy. My working copy. Okay. Now today I'm writing one thing. I wrote 4 lines of code, which was perfectly working fine. Okay. This is not completed. I wrote 4 lines of code, which was perfectly working fine. And I saved that copy. Okay. And what I do? I save that copy. So I'll write here day 1. Okay. Next day I again came in. I wrote some another lines over here. But now today what happens? Due to these lines, some of the lines, this is not working. So what I did, I deleted this line on day 2 and I added one more line and I saved it here. So this is my day 2 of work. Similar manner I am developing. So earlier day 1, this code was working. Day 2, that code was not working due to adding some more lines. Then I again deleted some line, adding one more line. Now the code is working on day 2. Similar day 3, day 4. So what I'm doing, there are different versions here. I have to save different versions, or if I'm not saving, for example, this was working earlier. This is some version. This is some another version. This is working on day 2. But on the third day, I got to know whatever I did on day 2 was again incorrect and whatever I did on day 1 was correct. So again, I have to see, I have written 100 lines of code now. Day 3, day 4, day 5. Again, I have to go back and delete, and again, I have to remember what I've done in the day 1. So in this way, in local, I will not be able to maintain my copy of whatever I'm doing. I'm not able to track the records. So for that purpose, they came up with a centralized version control. Means there is a central server. So they came up with centralized version control. Centralized version control. Means whatever you are doing on day 1, you should push it to the central server. So there is a central repo, or you can say central server. VCS, version control server, or anything you can say. So central server. or you can call it as the repository. Repository. Or remote server, you can call it as remote also. You can call it as remote server. Now, whatever you have done on day one, what you can do at the end of the day, you can push it. Push the code at the end of day, EOD. Whatever you have done here on the second day, again, you can maintain that copy. So this became some central repository where you are maintaining your versions of the code. Day one, you did something, you released it, it was working. Again, day two, there are some more requirements came in. You added some line, but it was not working. You again change the code of the day one and day two. Again, it is working. So you push the code again. So for this one, you can maintain some version of the code. Means you can give the version. On the second day two, you can give some version. So both the versions are maintained. But there is a drawback with this central server. So what you have to do when you are working with the central server, every time you have to be in sync with the central server. You have to be in sync with central server. So if connectivity is lost, then the developer could not work until this connectivity is restored. So there is a drawback. So I'll write here drawback. Drawback of centralized version control. You have to be in connection with central server in order to perform the changes. So this was centralized version control. This you can term it as local. To overcome this drawback, they came up with distributed version control. Distributed version control. So what is distributed version control now? So now you have a local repo and you have a remote repo. Earlier, there was no local repo, only local working copy was there. Okay. Now what you can do? whenever you are coming to your office work. So already there is a remote repo. Now what you will do at the start of the day, whatever is latest in the remote repo, you can pull it into your local working copy or local server, local repo. And after doing the changes, after doing the changes, here what you have to do, whatever change you perform, you have to push it. Whatever change you have to perform, you have to push it. But here it is not like that. You can perform number of changes here without pushing it again and again. So pull once, pull once and push at the last. So perform whatever changes. Since this will be working as the same server, same repo as the remote repo. So you can perform the changes, all the changes over here, and then you can push it back later on. So this does not needs any connectivity, continuous connectivity to the central server. Push at the last. Whenever your work is completed, you can push at once. You don't have to push it again and again. So you don't need a continuous connection to remote repo. Instead, you pull a copy of remote repo in your local. And once all the changes are performed, you can push it to remote repo. So now when we talk about version control tool, we have two types: centralized version control and distributed version control. So method which is followed for centralized version control is methods followed is TFVC, which is Team Foundation Version Control, which is a type of centralized version control. And this is the old one. Okay. People still follow, some companies still follow that, but it is the old one now. Okay. Team Foundation Version Control. TFVC. Another method is SVN. Another can be CVN. And what is the remote repo here? Team Foundation Server. So implementation of, from where it is inherited. So implementation of TFS, Team Foundation Server. Team Foundation Server. And then the most popular and other one is distributed version control. So what are the methods for this? Git. Git is the most followed distributed version control. So method is Git, which is implementation of GitHub. Implementation of GitHub. Okay. So GitHub is by Microsoft. Okay. So implementation of GitHub. What is a GitHub? GitHub is a repository. Central repository. Okay. So what are the repositories here apart from GitHub? So GitLab is there. GitLab, GitHub, GitLab, Bitbucket, Bitbucket. So these are the different repository. Most popular is Git. Most popular. I'll write here. Most popular distributed version control. And here most popular is TFVC in the centralized one. But 95% they use Git only. Distributed one. No, maximum person uses distributed, not centralized. Because there is a drawback in the centralized version control. Only those people are using centralized whose applications are, they developed their application way back 10-15 years back. They don't want to switch it to the distribution version control. Okay, only they are running. So in the DevOps tool, first tool is version control. So you manage the source code in this centralized server, version control. Another thing is another thing here is, I'll do one thing.
Abhishek, this workflow can be only used if you have a source code, something like that. How about Microsoft products like Microsoft 365 services and other on-prem products like SharePoint, Exchange, and all the stuff? We can use same DevOps model to deploy softwares.
Yes, definitely. Okay, this is,
Okay.
I'm just explaining how it came into picture, how, okay, the
Yeah, I
very
got it.
basic.
Just I'm asking.
Yeah.
Besides the e-commerce, so we have a lot of on-prem products, right?
Yes, correct.
Also, hybrid model, we are supporting a lot of software applications.
Yes.
Using the same DevOps model, we can upgrade or we can,
Definitely.
yeah.
See, it is DevOps model in Azure. It is like you can say it can be integrated with different open source tools. Okay. Or
Okay.
different you can say enterprise tools. So that we will see into coming classes.
In later classes, we will have some demo and all scenarios, right? Use
Yeah.
cases. Okay. Because what my expectation is that,
I'll,
right, using PowerShell,
Mhm.
so probably need to deploy or need to amend few attributes and all those stuffs.
Mhm.
Yeah. So yeah, probably I'm expecting more safe models on this.
Okay. I cannot see all the scenarios because that is never possible. Okay. But yeah, what are the
No, one
scenarios?
or two scenarios fine for
Yeah.
me. I will
But
try
what
to
you can do,
incorporate whatever.
you can learn out of all those things what we will be doing.
Okay,
Okay.
okay, okay,
Huh.
okay.
And then you can definitely implement that thing at your workplace, whatever are you are doing, right? So that will
Yes, you're
definitely
right.
help. Yeah. So second here is second tool I'm talking about is second DevOps tool. So it's continuous integration tool. Continuous integration and continuous deployment as well at the same time. CI and CD. But before that, here I'll tell you, since we will be learning Azure DevOps, so here there is a repository like TFVC and that. Both this centralized and for centralized and distributed version control both. Repository. In Azure. DevOps is Azure repos. So Azure repos can handle both. It can handle centralized version control also. It can handle distributed version. It's up to you what you want to choose. Okay. Like GitHub is the repository which is based on totally distributed version control. Here TFS is the repository like which is totally distributed, depends on centralized version control. But in Azure repos, they have Azure, Microsoft has implemented both. So it's up to you what you want to choose, centralized or distributed. Okay. So repository in Azure DevOps is Azure repos.
So Abhishek, Azure repo means TFS?
No, it's not TFS.
Ah,
Okay. You can choose whether you want to use Git or whether you want to use TFVC.
uh-huh.
See, TFS is, you can say, on-premises version of the repository of TFVC. TFVC is for cloud, central repository, cloud repository, you can say.
Correct. Uh-huh.
TFS is different. It is on-premises server. Okay, Team Foundation server.
Mm-hmm.
Earlier, it was TFS. There was no TFVC. TFVC, they just created out of TFS. That's why I have written over there implementation of TFS into the cloud. Got it? What I'm saying?
Okay, got it.
Yeah.
And
TFS,
Azure and Azure Repos is altogether the new product by
it is
Microsoft
a cloud product.
cloud product.
It is a Microsoft cloud product. Got it?
Which include both.
So it includes both TFVC as well and Git as well.
Got it.
Yeah. And Git is a product of Microsoft only. Okay. Earlier it was used as an open source or enterprise tool only, GitHub. But it is a product from Microsoft only. Okay. So like companies have different products. Even if they are coming from the same company, then also they have different products. So continuous integration and continuous deployment. For this, if I talk in Azure DevOps. So in Azure DevOps, we have, for continuous integration, we have build pipelines. Build pipelines. So build pipelines used to build the source code. Source code. And it is of two types. What are the two types of build pipelines here? One is the classic editor pipeline. Classic editor. Now this classic editor is, this classic editor pipeline is a UI based pipeline. Why UI based? Means you can choose the steps with your mouse. Okay, you can choose the steps with your mouse. That's why I'm saying UI based. You can see what steps to add in the pipeline, and you can drag and drop the steps using the mouse. So that's why this is a classic editor. Another type here is YAML. YAML means YAML code. I'm talking about code. Okay. So YAML based pipeline. So in the YAML based pipeline means pipeline in the form of code. And this type of pipeline can be maintained with your repository only. You can maintain that pipeline code into your repositories. And you can maintain the versions of your pipeline. Since it is as a code only, so you can maintain the versions of the pipeline. So there is a YAML language, okay, which is followed here. What is YAML? So YAML is yet another markup language. So they follow YAML code. So these are the two types you can write the pipeline. Now here, if you follow classic editor, this can be used only for build. You can use deploy also, no worries. Forget it. Okay. So here you can use, this is the build pipeline to build the source code. And then there is another pipeline, which is the release pipeline. To deploy the artifacts produced, and published by build pipeline. Okay. So there are build pipelines and there are release pipelines. Now I'll write, there is a catch here, you can deploy also. Not only you can build, you can deploy also. Okay. So you can deploy as well using build pipeline as well. Okay. You can deploy as well. Not only build. Okay. Apart from the release pipeline, you can deploy using build pipeline also. But with release pipeline, you get special, you can say, some more services, or you can say not services, I'll say, what to say, I'm not getting the word, but yeah, you get some more not reliable, I'll say, but sorry, I'm not getting the word, but you get some more anyone can get that, me get that word, or
A consistent, more
not
consistent.
consistent properties and all. Okay, some more properties you can have with the release pipeline. Okay.
Okay.
Yeah. I'm not getting that single word, what to say. Okay. So you can be more efficient using release pipelines, which is not the case with build. Pipelines when used to deploy. There are different options with this, like classic release gates are there, all those things. That's why. Okay. So there are two pipelines, build pipelines and release pipelines in Azure DevOps for like for having continuous integration and continuous deployment.
So, what is the you can say the technical difference between build pipeline and release pipeline?
Yeah, no, not technical. Like for build, you can build the code using build pipeline only. You cannot build the code using release pipeline. But using build pipeline, you can deploy as well. But you will not get all the, you can say, scenarios or all the steps or all the properties of the release pipeline with the build pipeline. Definitely you can deploy. Okay. But more efficient deployment is using release pipeline only. There are properties like release gates. You can attach your work items, all those things with the if you are doing a release or you are deploying using the release pipeline. But you cannot perform all those. I'm just talking an example. You cannot perform all those options using the build pipelines if you are deploying using the build pipeline. Okay. So build pipeline can do both build and release, but release pipeline can specifically only do release. This is specific for releasing only, for deploying only. Okay. That's what. So Azure DevOps. And now if I talk about enterprise tool here for CI/CD, enterprise tool. So enterprise tool here is Jenkins. Okay. Jenkins. So in Jenkins, you have different types of pipelines. So I'll write two types here as well. One is scripted pipeline. Another one is declarative pipeline.
So Jenkins is a third party tool, na?
It is
That
third
is
party. It is
free,
open source.
open source as well.
Not used in Azure DevOps. Okay, you can integrate it with Azure DevOps, but definitely this is third party tool. Okay.
So Jenkins is a language, or is that, I mean, the tool which is going to integrate with Azure DevOps?
No, it is a tool. If you want, you can integrate it. If you're like, if in your organization they have integrated with Azure DevOps, then definitely you can use it. But mostly, if you're working with Azure DevOps, it will be build and release pipeline. Whatever work is done by build and release pipeline, Jenkins can also do it. Okay. So this is Azure DevOps tool. This is a Jenkins tool. This is enterprise tool. Okay. Not belong to any cloud technology or something. Open source. So in scripted like pipeline, Groovy script is used. Groovy language or Groovy script, you can say. Okay. So scripted and declarative pipeline. And again, there are two more types. Not in a way to write the pipeline, but in a stage based. So you can have single stage pipeline and you can have multi-stage pipeline. So you have to create a different pipeline if you want single stage pipeline here. If you want to create a different pipeline if you want multi-stage pipeline. But here by default, it is a multi-stage only. You can either create single stage, either you can create multi-stage. Okay, in same pipeline only you can create. You can
So-
add the stages.
So I was saying multi-stage means, I mean, the build, testing, and final deployment. Is that mean multi-stage?
Right. See, build and test and publish is one stage. Deployment is another stage. Okay. So in
Okay.
one stage, you are building the code, you are publishing the code. Okay. You are testing the code, you are restoring the code. That is all that comes under one stage only. And that stage can be termed as a build stage. Another stage can be termed as a deployment stage, where you will deploy. So these are called stages. Okay.
One more time, I was saying the above you write build pipeline and release pipeline. Build pipeline, I mean, it's a self-descriptive where you are building and deploying the code, right?
Mm-hmm.
And that could be the YAML base,
Yes.
where our YAML code will going to ensure all those things.
Yes.
And release pipeline is a drag and draw, and when created the
This is UI based only. This is UI based.
this is why basically you create the steps and integrate and set one after the steps.
Yes, correct.
So there's a release pipeline automatic by default available in Azure DevOps.
Yes. Here you will not get that UI and all. Like UI you get here also. Okay, in Jenkins also you will get nowadays. Earlier it was not there, but nowadays they implemented in Jenkins as well. So this is a continuous integration and deployment. So you can deploy. And then later on, the most important after deployment is continuous monitoring. Continuous monitoring. So there are two types of monitoring. application monitoring, and log monitoring. So for application monitoring, if we talk about, means how much CPU is consumed by your application, how much memory is consumed by your application, what is the incoming traffic to your application, what is the outgoing traffic to your application. So all these things in the application monitoring. So you can monitor your application with this application monitoring tools. Now, application monitoring tools, if I talk about Azure. So in Azure, for application monitoring, we have application insight, or you can say Azure application insight. Yeah, Vamsi.
Grafana will also be covered in this, or
Can you come again?
Grafana should be covered in this course along with the Azure DevOps?
I'm not getting you. Can you come again? What tool? Which tool you
I'll
are?
put in the
Grafana.
chat.
Grafana.
Yeah.
Grafana. I'm coming to that. Okay.
Okay.
So Azure application insight. This is your application monitoring tool for Azure. If I talk about enterprise application tool, so it is most, you can say, common and popular one is Prometheus and Grafana. Okay. Prometheus and Grafana. So Grafana is the dashboard over here. Dashboard. And Prometheus is the server which collects the metrics. Prometheus is a metric server.
Means you are saying कि Grafana is implemented over Prometheus.
Prometheus, yeah. Prometheus and Grafana are, you can say, deployed. So Prometheus server will collect the metrics and Grafana server will display the dashboard of those metrics. Okay.
So
So
both
these
are
two will be covered in this, Azure DevOps course.
I'll be covering that. Okay.
Okay.
I'll be
Sure.
implementing that and will show you. Okay.
Okay.
And here the dashboard is Azure Monitor. Azure Monitor is the dashboard. There are many other enterprise tools as well. If you name it, there is App Dynamics. There's App Dynamics. There is Solar Winds. There are more than 50 monitoring tools. But the popular one is Prometheus. Okay. Now let's talk about log monitoring tools. So in the log monitoring tools, if I talk about Azure, so in Azure, we have Azure Log Analytics. Azure Log Analytics. And again for checking those all into the dashboard, we have Azure Monitor only. Azure Monitor, which can be used as a dashboard. And if I talk about enterprise tools, most popular one is EFK. This is your Elastic FileBeat and for Elastic FileBeat Kibana. Now Kibana is the dashboard here. To check the log metrics. So these are the tools for Azure as well, for enterprise tools as well. So this is how DevOps came into picture. I can show you a DevOps dashboard. So this is our Azure portal. In the Azure portal, if you search for Azure DevOps, so you will get this type of icon in the service, Azure DevOps organization. Click on that. Click on, if you don't have, then you have to get started with Azure DevOps. So it will ask you to create an organization, but I'm just showing you as I already have an organization. So I will click on my DevOps organization. You can see that this is my, now it will ask whether your organization is created using the default directory or it is created using Microsoft account. So always create your organization using default directory only, not the Microsoft account. Why? Because Microsoft account is created using an external account. See, gmail.com. So if I'll create my Azure DevOps using gmail.com, what will happen? Gmail is a third-party identity provider and Microsoft is providing Azure DevOps service. So I'll be facing some issues. Okay. You can say permission issues and all. So always create your Azure DevOps organization using your default directory. Now default directories means the identity which is provided to me by Microsoft on Microsoft.com, not the Gmail. Okay, so I created my organization using this, and this is my organization. Inside the organization, I have different projects. You can see. So if I click on my organization, it will take me to my Azure DevOps. This is my Azure DevOps. Inside that, you can create projects. Here, click on new project, get the project name, any project name, my, or you can say demo-project. Description you can give whether your project is public or private. Public means anyone can access from the internet. Private means no one can access. Like you have seen GitHub repositories, public repositories, right? GitHub Java web application. If you search for it, these are what? These are all public repositories. You can see these are public repositories open to everyone. Open to public. Anyone can access. Similar way, Azure DevOps also asks you whether you want a public or private. Always choose private only. Okay. In the advanced section, you can see which version control you want. Either you want Git or you want Team Foundation version control. So both are implemented here. Whatever you will ask, you will get it. Git, choose it. Now these are some processes, work item process. Scrum process, Agile process, basic process. Whatever process you will follow, you will get it. I'll explain you these processes when next class we'll start with DevOps properly with the DevOps, you can say components.
Tomorrow at 11 o'clock?
No, not tomorrow. Okay, tomorrow. Sorry, tomorrow. Yeah. Tomorrow at 11. So work item process, Scrum. if you create it, your private project will get created. See, this is your demo project created. And you can see here the components of Azure DevOps. Overview, dashboard, wiki, boards, repos. See, these are the repos. As of now, nothing is there. No code is there in the repos. So this is Azure repos. This is the version control here. Okay. Git, which uses Git. You can see all the commands as Git over here. Okay. Generate Git credential, Git remote add, Git, all the Git you will see here. Because you have chosen the project as Git, not TFVC. Okay. And then you can see pipelines. You can create pipelines over here. Create pipeline. Use classic editor. Click on that. Classic pipeline will be there. So as of now, no project, no repo is there. You can choose the code from anywhere, from the GitHub, from Git repo, from Git enterprise server, from SVN server, from Bitbucket, from other Git repositories. You can choose from anywhere. Okay. Or you can create YAML pipeline here. So if you will create a pipeline, see, use classic editor or use YAML. You can see Git YAML. If you click on YAML, a YAML pipeline will create. You can create a YAML pipeline.
So are we going to learn YAML as well?
Yeah, sure. Okay. Mostly I'll go through YAML only. Because in some days, the classic editor will be disappeared. Okay.
Yeah, YAML is more
Yes.
used to.
So, and there is you can say, project. Okay. There's a project. It is a full-fledged e-commerce project, which will be deploying here using all the components. We'll see each and everything. So this is like you can say that project or lab with that project specifically, you can say designed for by Microsoft only. Okay. So if you can see that project, I'll show you in the GitHub. Okay. This is a template project for e-commerce. You can say working project only. Okay. Now if you will see here, you can see this is a kind of e-commerce website. You can choose brand type, everything you can do over here. Okay. So this is based on .NET. So using this project, template project, we'll see each and every components of Azure DevOps. We'll implement this project, and using this project only, we'll create the pipeline, we'll create the repos, we'll create everything. We'll learn the Git also. We'll learn pipelines. We'll learn everything using this project. Okay. Once we do all these labs using the project.
Can you share this link in the chat,
I'll be sharing. Okay. I'll be sharing this, you can say, lab link. Okay. So there are total of 17 labs, and each and every aspect is covered in this lab. Docker, everything is covered. Okay.
So we are going to chat in Docker and Kubernetes.
Pardon?
We are going to champ in Docker and Kubernetes.
See, wait, let me stop the recording. Okay.